friends, my name is Yashwant. I am from CSC department. Today my topic is about nanotubes. Nanotubes are made by winding single sheets of graphite with honeycomb structures into very long thin tubes that have a stable, strong and flexible structure. Nanotubes are the strongest fibers known today. One nanotubes are being investigated as gelation and viscosifying agent. For example, nanotubes based on molybdenum alpha lactalbumin present some advantages over conventional viscosifying and gelling agent. Is estimated to be 10 to 100 times stronger than steel per unit weight. These are the nanotubes we can show in figure. Next, who invented nanotubes? Sumio Lejame is a Japanese physicist and inventor who was the first to clearly describe the formation of carbon nanotube and imagine their potential. Legumes in 1991 discovery and subsequent work spare a revolution in nanotechnology, which use materials measured in nanomaterial 1 billionth of a meter. There are two types of nanotubes. They are single-walled carbon nanotubes and multi-walled carbon nanotubes. Here, first one is single-walled and the second one is multi-walled. Difference between singles and multi-walled carbon nanotubes. Single walls carbon nanotube. Single wall carbon nanotubes are one of the allotropes of carbon intermediate between fullerene cages and flat graphene. Carbon nanotubes can also refer to tubes with an undetermined carbon wall structure and diameters less than 100 nanotubes. Such tubes were discovered in 1952 by Raduskevich and Lukyanovich. Multi-walled carbon nanotubes. Multi-walled carbon nanotubes consist of multiple roller layers of graphene. There are two models that can be used to describe the structures of multi-walled nanotubes. Next, uses of nanotubes. Such supersonic fibers will have several applications such as woven fabric and textile. Transmission line cabins and body and vehicle armor CNTs are also being employed in order to make textiles strain resistant. Nanotubes have high tensile, so they are strong in tension and resist being stretched. Like graphene, nanotubes are strong and conduct electricity because they have delocalized electron. Nanotubes can be added to the other materials, for example, in sports equipment, to make them stronger. Carbon nanotubes cupcakes may help in terahertz laser light. Carbon nanotubes for cleaning polluted water, boosting solar energy storage by a factor of 10,000. Tubes by the ton for more efficient electric transmission line. Molecular syringes, probes, and bioelectronic nozzles. Nanotubes acts as catalyst when an electric current is passed through them. This enables them to donate electrons to molecules that come in contact with the reaction site. The reaction is similar to what happens in fuel cells, genset, so further research may help in making better fuel cells. Next, nanotube thermosols hold as a energy source. The new thermocells use nanotube electrodes that provide a threefold increase in energy conservation efficiency over conventional electrodes. One of the demonstrated thermocells looks just like button cell batteries used in watches, calculators, and other small electronics. One key difference, however, is that these new thermocells can continuously generate electricity instead of running down like batteries. The research netted other thermocells as well, including electrolyte fixed filled textile separated nanotube sheets that can be wrapped around pipes carrying hot waste streams of manufacturing or electric power plant. The temperature difference between the pipe and its surrounding produces an electrochemical potential difference between the carbon nanotube sheets, which thermocells utilize to generate electricity. These are the pictures in we can show nanotubes can conduct electricity and use it as energy. Nanotubes can generate electricity. A new material made from carbon nanotubes can generate electricity by scavenging energy from its environment. Summary: engineers discovered a way to generate electricity using tiny carbon particles, then create electric current simply by interacting with organic in which they are floating. These are the photos with nanotubes can generate electricity. Examples of nanotubes can generate electricity. Particle power. The current version of particles can generate about zero point 0.7 volts of electricity per particle. In this study, the researchers also showed that they can perform arrays of hundreds of particles into a small test tube. This packed bed reactor generated enough energy to power a chemical reaction called an alcohol oxidation, in which an alcohol is converted to aldehyde or a ketone. Usually, this reaction is not performed using electrochemistry because it would require too much external current. Because the packed bed reactor is compact, it has more flexibility in terms of application than a large electrochemical reactor. Zhang says the particle can be made very small and they do not require any external wires in order to drive the electrochemical reaction. Here right side is the one diagram. This is middle one is gate oxide and the left side is source and the middle one is gate, and then in that between the straight are carbon nanotubes and is the rain, and the down of the sky blue color is silicon oxide and blue color is silicon made. About electric generator source, hydro power uses powering of flowing water to create electricity. Nuclear power comes from nuclear fission process that generate heats, which is used to generate the steam that rotates the turbines to generate electricity. Coal, natural gas, biomass, wind, oil, solar, these are the generate electricity materials. How electricity is generated? Electricity is produced when mechanical energy is harnessed and used to rotate a turbine. The mechanical energy to spin the turbine can come from a variety of sources, including falling water, wind, or steam from heat generated either by a nuclear reaction or by burning fossil fuels. Thank you, friends. This is the topic about nanotubes, uses of nanotubes, and nanotubes conduct electricity. Thank you. Presented by BVH1 from CSA department, first year BTech. Thank you.